Space, the final frontier. For centuries it's beckoned us, challenged us, inspired us. We've sent probes to distant planets, landed rovers on Mars, and even walked on the Moon. Yet one frontier remains largely unexplored: human intimacy beyond Earth. As we set our sights on longer missions, on building a future among the stars, we must confront the full spectrum of human experience. This includes the most fundamental of human drives: love, intimacy, and reproduction. While some might shy away from these topics, deeming them taboo or inappropriate for scientific inquiry, we must embrace them. To ignore them is to deny a fundamental part of what makes us human. It's time to ask the big questions. What are the challenges and possibilities of intimacy in space? How will microgravity, radiation, and the psychological pressures of space travel affect human relationships and reproduction? These are not merely questions of curiosity, but of survival, of ensuring the long-term success of our species beyond Earth. Imagine trying to dance in a swimming pool. Now, imagine that pool is in a spaceship, hurtling through the void. That's a taste of the challenges of physical intimacy in space. Microgravity, the weightlessness experienced in orbit, transforms simple movements into complex maneuvers. Blood flow, too, is affected, potentially impacting arousal and physical responses. But the challenges of microgravity extend beyond the physical. The vestibular system, which controls our balance and spatial orientation, goes haywire in space. This can lead to disorientation, nausea, and even vomiting, not exactly conducive to romance. Yet humans are nothing if not adaptable. We've engineered spacesuits that allow us to work in the vacuum of space. Rovers that can traverse the Martian landscape. Surely we can find ways to overcome the challenges of intimacy in zero gravity. Beyond the challenges of physical intimacy lies an even greater question: can humans reproduce in space? The answer remains shrouded in uncertainty. Cosmic radiation, a constant bombardment of high-energy particles from the sun and deep space, poses a significant threat to human health, particularly to reproductive cells and developing embryos. Microgravity also plays a role, potentially impacting fetal development and even the viability of pregnancy itself. While some studies on animals have shown promising results, the long-term effects of space on human reproduction remain largely unknown. And what about the ethical implications? Is it right to bring a child into the world, into the confines of a spaceship or a Martian habitat, without their consent? These are questions that demand careful consideration, a delicate balance between scientific progress and ethical responsibility. Let's not forget the psychological dimension. Space travel is a crucible, testing the limits of human endurance. The isolation, the confinement, the constant pressure. All of these factors can strain even the strongest of bonds. Imagine sharing a cramped spacecraft for months or even years on end with the same small group of people. Privacy becomes a luxury, a distant memory. How do you maintain a sense of intimacy, of individuality in such an environment? And what about the psychological effects of prolonged isolation and confinement? Studies have shown that these conditions can lead to a range of mental health issues, from depression and anxiety to interpersonal conflicts and even psychosis. If we are to send humans on long-duration space missions, we must be prepared to address these psychological challenges. We need to create environments that foster mental well-being, that allow for privacy and personal space, even amidst the vastness of space.